good morning, everybody. Thanks for coming out this early in the morning on this second day. And I know a lot of y'all are attending this conference with a sense of identity, a sense of membership to a particular community. You're identifying as a Rubyist or a Pythonista or a JavaScripter or a Clojurer. I would invite you to take the next 30 minutes to just sort of forget about that and think about things on a larger scale. And we'll get into that in a little bit. I'd like to start out by sharing one of my favorite parables. It's the story of the space shuttle and the horse's rear end. All right, so a fun fact. The official standard for the gauge of a railroad track in the United States is 4 feet and 8.5 inches. That's the distance between the rails of a train track. That is the standard way that trains are made and run in the United States. Now you might ask yourself, where does this number come from? And you would not be mistaken for wondering, because that is a weird number. I don't think anybody's favorite number is 4, 8.5, or I don't know. That's just not something that comes from a familiar place. So of course it is the United States. And at the time that the railroads were first being built, we were actually contracting from Great Britain. England was, at the forefront of railroads, and they were building them according to their standards. So again, imperial units, they check out. But that doesn't get us any closer to understanding where that number comes from. As it turns out, the British railway system has its vestiges in the carriages and the wagons that would run in the deep ruts of their old roads. For hundreds of years, this has been the standard width. But where did that standard come from? That's the question. Well, you have to go back about 1,000 more years to get this, chariots, because the first roads that were built in England were built by the Romans. The Roman Empire, of course, famous for their roads, created them everywhere they went, and it was central to their ability to rule and administer areas far, far away. So all those old roads, all those old routes that needed to be traversed by wagons followed the same width of the chariots that the Romans rode. And of course, a chariot is designed according to the width of the animal driving, in this case, 1 or 2 horses. So from ancient Roman horses, we have this standard for American railroad gauges. And of course, that goes all the way to the space shuttle. So the space shuttle, for 50 years, it served as NASA's primary vessel. It's what got us to the moon. And the solid rocket boosters that were manufactured, I think in Utah, they were transported by rail. And they needed to be designed in such a way that they could fit through the tunnels of the railway system. So there you have a Bronze Age technology, a constraint on the width of a horse's ass, dictating the standards by which we reach the heavens. I think that's a fascinating and just inspiring story. And if nothing else, teaches us that specifications and bureaucracies live forever. There's no escaping it. So anyway, this talk is about conventions. And conventions are really just to say how things are done. And breaking from conventions, I know a lot of the talks that I've seen are sort of going on a deep dive into a particular topic, exploring or maybe doing a survey of different languages. This talk is not like that at all. It's going to be sporadic and maybe have nothing to do with programming at times, and I hope that's acceptable. Hopefully it all ties together in the end. So bear with me. If you don't like what's being talked about, just wait a couple minutes. Anyway, so the whole point of what that example that I just shared with you is that everything comes from something. That might seem like a banal statement, but really everything that you see and interact with, it has a reason for existence. It has a history, this invisible chain, this causal chain from cause to effect, untold millions and billions of people inspiring and influencing the way that we use and think about things every day. Everything has a connection. Just look at your laptops, for instance. The keyboard format, the way that the keys are laid out, of course, have to do with the way that typists originally, used that in the original typewriters. That it was, in fact, influenced by things previous to that, too. The dimensions of screens, the byte ordering of the information going through your computer, the very words that you're hearing me speak to you right now, these aren't my words. These are words invented, they're invented by other people in a language. And in fact, they're the words that you use to think. We don't think our own thoughts. Everything comes from something. This very idea of tracing cause and effect itself is part of the Baconian tradition of the scientific method. This idea of inductive reasoning. You can trace cause to effect, and by changing a cause and looking at the way that the effect changes, you can learn some truth about the universe. And in fact, to go even more meta, the fact that I went out and actually talked about this as part of the method is itself kind of an extension of postmodernity. That we eschew this idea of a meta-narrative, this overriding story about the way things are and why they're meant to be, and just say that we need to deconstruct terms in order to try and find some grain of truth. There isn't one truth, but we can learn a few things by deconstructing that. And a lot of times that has to do with language. So in fact, in this talk, I'll be making a lot of comparisons between programming languages and natural languages. So why are we here, right? This is a polyglot conference named after Ruby and Python, two languages that honestly aren't that too much different. It includes JavaScript and Clojure, and next year it'll be called something else. But we're all here not because it's not because we are here to learn something about how we can be a better programmer per se. There's something deeper. I actually find it remarkable, and this is a taboo to read something off a slide, but isn't it remarkable? Humans organize themselves according to how they talk to computers. I think that's bizarre, right? We're organizing ourselves into tribes based on the particularities of how we talk to these machines. I don't think a science fiction writer 50 years ago could have imagined what we're into right now. This is bizarre. The fact that we're raising our hands and saying, yes, I'm a Rubyist. What the hell does that mean? And we gets us back to something that Freud talks about in Civilization and Its Discontents. That sounds really effing pretentious, banding about Freud. But this narcissism of small differences, yes. It's this great term to describe how things that are so similar to one another, we find differences just to be able to exploit them. When things are so similar, we have to create and invent reasons to dislike the other tribe. So for instance, Ruby versus Python. What are the differences here? I don't know. There's indentation sensitivity. Honestly, that's not too much of a deal. Haml, Sass, CoffeeScript, Rubyists love indentation, sometimes. There's enumerations versus comprehensions. There's a slight difference in the way that we look through lists, but that's kind of BS too, because Ruby has a similar syntax to Python in some ways. We have statements versus expressions, but honestly, I don't think most people are really cognitively aware of that most of the time. Implicit versus explicit. So, we're just splitting hairs here. There's so many similarities. They're both high-level scripting languages. They're both dynamically typed. They both have an interactive shell. They both share keywords and syntax to the point where, honestly, if you're not looking that hard, you couldn't tell the difference between the languages. And they all serve common purposes, too. These are both web languages in a large respect. Django and Rails both being one of the main drivers for adoption and innovation. They're used for the same thing. There's a project by one of my favorite programmers, Why the Lucky Stiff. Back in the day, he had this experiment called Unholy, which was this project that could compile bytecode back and forth between Ruby and Python. It lives, in absentia somewhere on somebody's GitHub that they rescued after he kind of disappeared off the internet. But even 5 years ago, that was sort of a major turning point for the relationship between Ruby and Python. Because back then, I guess there was a lot of reasons to fight, right? Nobody knew who was going to win this thing. We didn't know whether or not we needed to defend our territory as much. And honestly, the JVM has rendered all of this completely irrelevant. Everything can run on the JVM. We can trade, binaries and dependencies and all sorts of things across this universal virtual machine. Just as a brief aside, so everybody's a fan of the JVM. I find this to be a fascinating kind of story. The JVM, developed by a team that at the time was working on a language called Strongtalk. Now, I think there's a commonality of everybody in the room that we all love Smalltalk, right? It is the object-oriented programming to rule them all. It's a great language. Strongtalk was this language that was going to introduce optional static typing. So you could have stronger constraints on what was being passed around, which could allow for better optimizations. It could allow for you to actually understand what's going on and not have to guess what everything means in every context. Ruby would do well to have this. Anyway, this team was bought up by Sun And eventually what they were working on went into something called the hotspot VM, which became eventually the JVM. So there's this Faustian bargain that was struck, where instead of having this kind of awesome language, we have this universal common denominator. And sometimes I wonder which I would rather have, but I guess that's history. So yeah, moving on. Let's talk about semantics and syntax. This is one of my favorite sentences. This is Noam Chomsky's famous sentence, "Colorless green ideas sleep furiously." And it's an idea that's created, it's contrived to show that something that is syntactically correct can have no semantic meaning. He introduced this in his Syntactic Structures book as an example of something that it does. I mean, this sentence doesn't mean anything. Something can't be colorless and green at the same time, and ideas certainly don't have a color to begin with. And if ideas were to sleep, certainly they can't sleep furiously. This is a nonsense sentence, but syntactically, it all checks out. I think it's also interesting to kind of look at where English is coming from through its etymological roots. English, of course, is this big mishmash of Germanic languages and French. That's why nothing makes sense and nothing's spelled correctly. So if we kind of look at these words, individually, color comes from the French couleur, I guess. Green is a Germanic word, so in all different Germanic languages you have grün or something like that. Ideas comes from the Greek for ideal. Sleep, another Germanic word, so schlafen. And then furiously, which comes from the original Latin, so all the Romance languages have a word very similar to this. And if we look across the different languages, it's interesting to see the different etymological roots. Every language, of course, every society is going to have, pretty early on, some notion of sleeping. Humans sleep. You don't need a loan word for that. Unlike the invention of the computer, which would be the first thing that, kind of existed wherever it was invented, and every other language would kind of adopt a common word for that. Every language created their own word for sleep to begin with. So in English, it's sleep. French is dormir. Schlafen in German. How do you say that in Hungarian? Something like that. Yeah. I'm fascinated by Hungarian. I really don't know where this language is coming from, and I just haven't read up on the Wikipedia article yet. In Arabic, it's num, and Russian is spat. Totally different etymological roots for all of these words. Compare that to the word for pineapple, which is, I think, hilarious because everybody else can agree it's called ananas, except English. Pineapple? What the hell is that? Anyway, so influences. This has to do with etymological roots in some respect. Hopefully I'm tying these things together and it's not just this mishmash of random ideas. These languages, of course, are not created in a vacuum. And every language, of course, has a reason for existence, these invisible histories that are tracked. If you look at Ruby influences, we have an array syntax that's borrowed by C. This hash syntax, I guess, associative arrays in PHP. But then the more modern hash syntax was something that JavaScript did first. You have string methods of Perl. You have the begin, rescue, ensure, the loop, redo, retry of a language called Eiffel, which is really neat, designed by Contract. And you have post-conditionals, which first occurred, I couldn't figure out the original introduction of them, but cache, JOS, or algol, one of those where you have a statement, if, and then the conditional. The Python influences are interesting as well. Python most directly influenced by the language ABC, which I actually haven't seen in real life, but the statement nesting indentation, that comes from that language. From X import Y, that's from Modula 3. Forget Modula 2, that's totally irrelevant. Multiple dispatch came from a language called Dylan, which a lot of people still love, and C++, which a lot of people don't love. And then expressions versus statements, the fact that there's a distinction between those two, that's very much a Fortran thing. As far as JavaScript goes, the name obviously comes from Java, very confusing. Semicolon usage, I'm gonna say Java again, why not? Prototypes come from a language called Self. The fact that actually we're not dealing with classes, we're talking about prototypes, and you can't just treat them like classes, I think that's a fascinating thing. That comes from Self, the language. And lambdas, I guess you could say that comes from Scheme. As far as closure goes, I'm not as familiar with this, so this is just kind of random guessing. Let's say the S expression syntax, that's Lisp. The runtime, it's built on the JVM, so Java there. You can use all the Java libraries. Functional paradigm, somewhere between Haskell, Scheme, and ML. And the concurrency model, maybe Erlang? I don't know. It's hard to find the sources for these, and I don't really know this. So let's compare how that actually manifests itself. In the simple examples, they are nearly identical, right? You have an assignment of a variable and then an addition expression, right? JavaScript, you have the var, and then Clojure, that looks a little bit different because you're defining a value. Variables work differently in Clojure, but for the most part, very much the same. As you get into kind of a more complex example, you have Ruby. This is for selecting the even numbers out of a collection, right? In Ruby, you're using select. In Python, you're using a list comprehension. JavaScript, you're filtering through a function that's being passed in. And then Clojure, that just looks like a hack. That's awesome. Very, very short. So you see the differences manifesting themselves as examples become more and more complex. And these characteristics are borne out across different languages as we start to try and categorize the different languages on different axes, right? So you have the object-oriented versus functional versus procedural versus imperative, all these different paradigms. I think that's a common trope, is that you're supposed to learn one of each so that you can learn how to think in those different paradigms, because object-oriented programming isn't going to do you well in every situation. I mean, you have the typed versus untyped thing. Yeah, I'll just go through strong versus weak, static versus dynamic, classical versus prototypical, compiled and interpreted, single versus multiple inheritance. The first one is better. Mutability versus immutability. Second one's better. Commenting systems. I kind of like the octothorpe. Terse versus verbose. I'm a big Objective-C fan. Verbose, it's awesome. And then textual versus graphical. The fact that there are graphical languages like PA, where you actually have an image and you interpret the image by running through the different swatches of color, that blows your mind. But all the languages are equivalent. All the languages that are useful are going to be Turing complete, which means that they can all solve the same set of problems. However, as an exercise of semantics, what this might actually look like changes quite a bit. And that gets into the whole notion of denotation. So for instance, denotation is this how we specify things in the world, but the things that we're specifying actually aren't the things that we're talking about. So for instance, if we're talking about chair, either spelling it or saying it, that's, you know, what it might look like on a spectrograph if you say it, the word chair. We're talking about, you know, these things, right? Any number of these things. It doesn't matter what kind of chair it is, they all kind of fit in that section. However, there might be a different connotation, right? That one of these, some of these are stools, some of these are lounge chairs, some of these are desks. So they're all chairs, the denotation there, but connotation, it's a little bit more specific. That's a random aside. Another random aside, the word bed looks like a bed. Just gonna throw that out there. So there's this awesome talk, or this seminal paper rather, called Basic Color Terms, Their Universality and Evolution from 1969, which is a very interesting period for linguistics. Brent Berlin and Paul Kay came up with this idea. They surveyed just hundreds of languages around the world in order to understand how we think about color. And they came up with a couple different findings. The first of which is that every language that they ever found makes a distinction between light and dark, which makes sense, right? If we think about this in an evolutionary psychological perspective, where languages exist to serve a purpose and humans have common purposes, we all live in a day and night cycle. I mean, unless anybody's in the North Pole or something. So it makes sense to distinguish between light and dark. The next color, if they have a word for another color, it's going to be red. Red is a dangerous color. It means blood. It means something's happening. I either killed something or I'm being killed, right? After that, you have green or yellow, maybe one or the other, or both. And then the color after that is going to be whatever the other one was. So when you have 5 color terms, they're going to be black and white, red, green, and yellow. Green and yellow for vegetation, I'm guessing. And the next word, almost always, it's blue, which describes the sky, it describes the ocean, water. So that's the way that those things go. More tertiary colors like brown, purple, pink, those happen sometimes, but they're not necessary. In fact, and this isn't to say that languages that don't have a very large vocabulary for colors, that's not to say that they aren't useful. The ancient Greeks, for instance, one of the most advanced cultures that ever existed, they didn't really care much about colors. The color that they used to describe, the term they used to describe the color of the sky was bronze. Bronze. The color of a sheep was wine. This might just be Homer being poetic as he is, but it doesn't look like the ancient Greeks actually used color to describe things as a useful way. Compare that to, for instance, in Italian, you have the word azzurro, which is used to describe the color of the sky or the ocean, which is different than maybe the English word blue. Which brings us to one of my favorite and most interesting examples of languages, the Piraha language, studied by Daniel Leonard Everett for 30 years. The Piraha are a tribe of 400 people in Brazil, and they've been surviving outside of the influence of Brazilian culture successfully for a very, very long time. They live in the jungle. And here's some interesting things about the Piraha language. It has a tiny phonetic inventory. It only has 8 consonants and 3 vowels. 3 vowels is about as few as you can get. And 8 consonants, that's pretty close to the record. The word, like the ha and na, I believe that those are not contrastive, meaning that you say one or the other, they're interchangeable. As a result of this, you can actually whistle this language, and it's still intelligible. People whistle this language in the jungle to communicate over large distances. There are no relative clauses or grammatical recursion, which actually flies in the face of something called the Chomskyan idea of the universal grammar, that there's this universal way that we all have about thinking and that all languages encode that. Turns out, not true, according to this, if this is a good counterexample. There are no cardinal or ordinal numbers in this language, which means that you don't count. You just say few or many or none. There are no unique words for color. So although they make this distinction, the term they use for red is bloodish. Interesting. But the most interesting of all, and what makes Piraha so important to study, and what kind of brings out this example, is that it has an epistemological necessity as part of its grammar. So if you make a statement like, I saw a snake, you have to say there is a snake. You have to say why you think that there's a snake. You either saw it, you perceived it yourself, or you heard it. You either intuited it, you saw some snake tracks, or you saw some bones of an animal eaten by a snake, or maybe somebody told you about it. One of those 3 things. Every statement has to be backed up by some etymological truth. There are 6,000 natural languages in the world, and hundreds of them die every year, if not more. Natural languages encode a way of thinking. This is all a roundabout way of explaining that every language encodes a unique combination of constraints and ideas about the way that we think and perceive the world. Every programming language, similarly, is encoding a unique and fascinating take on how to think about ideas, how to do computation, how to model the universe. So it's important to have some flexibility in that. That's the strength of polyglot programming. Which brings me to another segue. English as the universal programming language. Of course, what allows me to speak in Hungary in front of an audience of many different language speakers, but the universal common, or at least the common language is English, is a testament to the fact that programming is all in English. You need to know English to program. What do we lose out on that, though? That's a question I often wonder about. Like Korean, for instance. Korean has the best writing system of any language in the world, in my opinion. It's fascinating. It's an aspect-oriented one. So anybody that loves aspect-oriented programming, you'll love this because the characters combine, this character right here, it's actually 3 sub-characters. You have this character, cha, ang, ge, chag, for book. I might not be saying that right. So it's either consonant, vowel, consonant, or you have vowel, consonant, or consonant, vowel. This is the word for woman, yosong. The 0, that null character, that actually just is a blank space, so it actually starts with a vowel in that first one. And this language, the Korean Hangul script, was designed by a single guy in the 5th century. It's a celebrated process. I mean, this is probably the best thing that they ever came up with. It's a small inventory of consonants, and they're all very simple, and they combine into these language clusters. These are the consonants. These are the vowels. The vowels look very similar. They're mostly lines with maybe another line sticking out of the middle. And it's very legible. You can learn how to read Hangul in about an hour. And you can write this. You can write in English in Hangul. You can, or in any other language. You can transliterate it. It makes me wonder what would happen if our programming languages weren't all in ASCII, right? Latin is an interesting character set, but it's not the only one. Another example, Arabi, so Arabic. Arabic has not the best writing system, I'd say the most beautiful writing system by far. You read right to left, of course. Why did that not show up? Anyway, you read right to left, but there are three forms. You have an initial, a medial, and a terminal form. So the letters look different based on where in the word they show up. So if they start up at the beginning, that first letter ba, it's going to look like that. If it's in the middle, it's going to have the lines and then just one line up with a dot underneath. And then if you finish it, you write the character in totality, extending from that first line. And those lines can extend for as long as they want without changing the meaning. So it actually makes Arabic a very flexible language if you're trying to fill vertical or horizontal space. There's also another interesting property of Arabic, which is that this is the word for kataba. This is he wrote. It uses something called a triconsonant Semitic root, a Semitic triliteral root. The letters KTB, anytime you see this in an Arabic word, it represents writing. So to flesh this out, kataba is he wrote, katabna is we wrote, yaktubu is he writes, naktubu is we write. This works for vowels too, or for nouns too. So katib is writer, maktab is office. You can look at a word you've never seen before, and so long as you understand and recognize the root, you can read the word and basically understand what's going on. There's a programming language called qalb, which is the Arabic for heart. It's actually mostly performance art. It's a language in Arabic, but mostly it's just scheme that's been transliterated from Arabic and reads right to left. I don't think anybody's actually using this, but it certainly bears exploration, I think. Another interesting thing is that Unix commands, they're so short and they often omit vowels. Arabic similarly has implicit vowels, so you don't write the vowels. Unix would fit right in with Arabic. So that's another interesting thing. So finally, let's talk about P equals NP. There is no unifying theme to this talk. P equals NP. For anybody that's not as familiar, P problems are considered easy for computers to solve, whereas NP problems are easy to check but very, very difficult to solve. An example of this is, let's say you have a pile of rocks and you want to divide them up into two piles of equal mass, and each rock has a different mass. With just 100 rocks, the number of combinations that you'd have to check is bigger than I can actually read out, right? This is amazing. 1 million computers doing 1 million checks every second would still take the age of the universe to find a solution to this. Very, very difficult to find the answer. It would take a second on any of your laptops to actually check if the answer is correct. Which brings us to quantum computers. Somebody tried to hack this P equals NP conjecture to actually figure it out, to see if classical computing was in fact limited, but quantum computing would not be. You see, with quantum computing, you don't have the same constraints. You have this superposition, you have this wave function that is in all the different positions until you observe it, and that collapses the wave function. So you have this wave of probabilities of states. And then ultimately, the idea was that the lowest energy level would be the solution to this problem, that we could solve these NP-hard problems by just kind of throwing quantum bits at it and see what solution had the lowest energy level. As it turns out, that didn't really work. But quantum computing is still promising for other reasons. This is an XOR gate. The XOR function does the following. It returns true if either A or B in its input is true. If both are true or both are false, it returns false. With quantum computers, they can go the reverse direction. So in XOR gate, you can go backwards through the XOR gate and figure out whether that 1 that you see on the right-hand side was A coming from A or B. The rules of quantum logic and quantum logic gates are so significantly different that, in fact, I see that there's a potential that we could release ourselves from all the conventions of von Neumann architectures in computers and start to establish a new way of computing. So I see that as kind of the way to break through all of what we discussed. All right, what the hell is the point of all this? There's no right way to do things. There are no sides. We are, of course, a product of our culture, but we should not be beholden to it. Again, we all come here with strong identities and strong associations with our communities, and that's important. But let's not be blindsided or short-sighted in how we understand our role in all those contexts. Let's stay curious, let's look around, let's introspect, question everything, and I don't know, the future's bright. There's a lot of cool stuff out there, and that's why we're all here. I'm on the internet, Mattt with 3 T's. That's GitHub and Twitter. Reach out if you want to contribute to that discussion or just say hi. Thanks.
Thank you. Is there any questions, maybe?
So you mentioned that Python and Ruby are quite similar. Do you know the reason why both were invented?
No, please, tell me.
I don't.
Oh, okay.
I'm asking, it's a question.
Why Ruby was invented? Ruby was created by Matsumoto-san in Japan as an extension. I mean, the reason it's called Ruby is it's like the next Perl. So the kind of tasks that Perl were really good at, string processing certainly, and the web, maybe, CGI stuff. That was the reason for that. I'm not as familiar with Python's upbringing, but I guess I was more influenced by ABC and Fortran, that sort of influence. So those are the different ways that those languages came about. It's interesting to see how similar they converged upon in terms of what they're ultimately used for today.
Thank you.
Sure. Another question over there on the right.
It feels that fashion is mainly fashion in technology pretty much kills diversity. I mean, do you know any way, or if you have like an advice on how to actually bypass fashion in order, to maybe in any kind of company or in a team to actually, encourage diversity and diversity in things like that?
So the problem is that everybody wants to use the hotness, right? Everybody wants to use the sexy new thing.
Or you're pressured by your peers.
Or there's pressure by your peers to adopt it. I think the pressure is ultimately what allows us to actually settle on a common thing. I mean, if everybody programmed in a different language, that'd be very difficult. The fact that we can walk into a job and not have to have any training to be productive, that's a good thing. How to encourage that in an organization, to encourage new solutions, that's a tough one, right? Because you don't want to bet on a losing technology. That's why you have all these random pieces of code written in unmaintainable things. I honestly don't know if there's a solution to that, other than maybe your organization encouraging experimentation, but ultimately, I don't know, there's a middle path, right? Knowing why you're choosing a solution. I mean, don't just go out and use Mongo for no reason if everybody else is using Postgres, for instance. But if it's actually solving a real problem, maybe give it a try, that kind of thing. So understand why you're making that decision and respect other people in those decisions, I guess.
Because sometimes, I mean, you had an example with that language from a tribe which had like 8 consonants, and so
right.
So that was maybe a very nice language, but that can happen also in technology. Like you have some very nice technologies, but which everybody forgets because English is popular.
Right.
So that's, or like Korean is awesome, but nobody's actually using Korean because English is very popular.
But still, a lot of people use Korean. And the weird thing is that these languages, they may lie dormant for a long time. Ruby, it was maybe, it's a contemporary of Java. It's been around since 1995. It took 10 years for anybody to start using it for anything, namely Rails. Lua, I think, is the best comparison to the Pinahan language because it has such a small feature set. And we find it flourishes in scripting of like World of Warcraft. So all languages have a potential use case. Maybe it takes a while to discover what that is. So yeah, either way, it's a fascinating thing. I encourage experimentation, but I guess that's what 20% time or weekends are for. Yeah, thanks. Cool, any other questions? Sure, one in the back.
Okay, so thank you for the talk. And how do you apply this kind of diversity and openness and a way of thinking out of the box, respect of the way we usually think to Python, Ruby, JavaScript, and so on. So how would you like to see the future of those languages with respect to this kind of concept?
Sure. I think we're already seeing a lot of that. A lot of languages, I'll speak from an example that I know quite a bit about, Objective-C. What we see is that there are some people that really liked the reactive patterns of ASP.NET, and now there's this amazing library called Reactive Cocoa, where we're taking something from C# and ASP.NET and applying it to Objective-C in a way that usually you wouldn't expect to fit. And I think we see that pattern a lot already. People bringing in patterns from different languages, trying out new things. A lot of people bring Ruby over, the string APIs over to different languages that are a little bit more verbose or limited, or the collectors and the numerators. So it's that sort of cross-pollination. That's sort of the first step. In order to understand where those potential crossovers may exist, I guess it's all about research and just critical thinking. So, cool. I think we're out of time, but if you see me around, please say hi and feel free to chat. Thanks.